So CSMA can reduce the possibility of collision, but it cannot eliminate. Okay, using the CSMA, it can reduce the possibility of collision compared to Aloha. Okay, but it is not the meaning that it is going to completely remove the or eliminate the collision. Okay. You can just observe there is a diagram here. So the station A, B, C, D are connected to a shared media. So here the possibility of collision still exists by using CSMA also still it is existing. So when station sends a frame, it still takes time before sending. So for what purpose? So consider here station B sends the media at time t1. It may find that the media is free at time t1. Okay, and immediately the station starts sending the data. At time T2, just observe, I am just focusing on the station B and station C. At time T1, B senses the media, it finds that it is idle. Okay, and at time T2, even station C, maybe after a few seconds, even C senses the media, it finds that the station is idle because it takes some amount of time, propagation time, to reach the first bit of station B to this particular point. Okay, it will take some amount of time. Before that, there is a possibility C also sends the media and it finds idle, and that station also start sending the data. Okay, so at some point of time, what happens? There may be a collision. Once the first bit of the station A meets with the data that is sent by station C, then there will be a collision. So the two signals from both station B and C collide and both frame destroyed. Okay, once it is there is a collision, so both the data get corrupted. Okay, so that is the station from B, the frame that is sent by station B, and also the frame that is sent by station C. So once again it requires resending of the packet. So you can just observe here the blue color. So this blue color indicates that is the data sent by signal, or the data or signal it's sent by station B. And this one you can just see the gray color indicates, or you can just observe on the blue color. Okay, light blue color, it indicates area where signal sent by station C. And this gray color shade indicates, so this is a time during which there is a collision happen. Okay, there is a collision happen of frame from station B and also frames from station C. Okay, so you can just understand that using CSMA, it is not possible to eliminate the collision, but to some extent it is possible to reduce it. So even though you can just observe here, even though the station B sends the media at this time, it was idle and this station started sending. But at time T2, okay, maybe not much difference time between T1 and T2. So C also finds it is free. Maybe by that time, the data sent by B, it may not reach the first bit of the frame. If it is not reached here, it finds that the station, or the not station, the media is idle. Okay, the media is idle. Then C starts sending the data. So then there will be a collision occurs. In this case, what is a vulnerable time? Okay, how to measure the vulnerable time for CSMA? The vulnerable time is the propagation time, TP. So propagation time means the amount of time it takes to propagate the frame from station A to station, or the specified station. Here consider it as D. The propagation time is the time needed for the signal to propagate from one end. Okay, this is one end, and to reach the other end. So whatever the total time, we call it as propagation time. So here the collision may occur when station sends a frame and other station also sends a frame during propagation time. I already told in the previous diagram. So this is the time during which the station B sends the media and it finds it is idle. Then it starts sending the data. Okay. So even station C at this time, okay, it is sensing the media. It finds that it is idle. Then it is going to start sending the data. Okay, so then in that case there will be a collision. But here, in case if the frame that is sent by station B, if it is reached at this point, okay, at this time, if the data of the station B it is reached at point C, then station C finds that the media is busy, then it is not going to send the data. Okay, so that's why vulnerable time it is set to propagation time. So during this propagation time of a frame, if any station sends the data, then there will be collision. That's why it is called as vulnerable time. So vulnerable time is nothing but it is a propagation time. Okay, so from T1 you can just observe. So this is called as propagation time from T1 to here. So vulnerable time is nothing but propagation time. So within this propagation time, if any other device sensing the media and if it is sending the data, so then there will be a collision. So vulnerable time is nothing but it is a collision period. If any station sends the data, definitely there will be a collision. So collision occurs, a station sends a frame and other station also sends a frame during propagation time. Okay. So this you understood from the previous diagram also. So if the station sends frame at the same time, if another station also sends the frame during that propagation time, so definitely there will be collision. That is, if the first bit of the frame reaches the end of the media, every station will refrain from sending. Okay. In case if the first bit of this frame, whatever it is sent by the station B, if it reaches here, then so this station is going to sense the media. In that case, it will return the media is busy. Okay, then C is not going to send any data. Okay, so that is how you can calculate what is the vulnerable time. So your vulnerable time means, so during this time, if any packet, if any data is sent, so definitely that leads to collision. So persistent methods, what are the different? So this can be categorized like sensing the media and sending the data can be categorized into three ways. Okay, so that is to reduce the collision. Still, this is just a basic concept used in CSMA. So how this CSMA concept can be enhanced using a persistent methods. So what exactly happens in persistent method? So what should a station do if channel is busy or idle? Okay, what a station should do if channel is busy or idle. So you already know that if it is busy, it has to wait till the media is become idle. Okay, the station should wait till the media becomes idle. In case if it is idle, so if the media is idle, obviously the station is allowed to send the data. So here in case if it is busy, so how long it has to wait? Okay, how long it has to wait, when it has to check the media is busy or not once again. So that depends on three methods. One is called a persistent method, the second method is called non-persistent method, third one is p-persistent method. Okay, we'll just go through these methods and we'll try to understand how these persistent methods works. Okay, very simple mechanism. The first one is one persistent method. So you need to write it here. This is one persistent method, the first one. First one is one persistent. So what is the meaning of one persistent? What is the concept used? So this is just the concept used when station finds the media is busy or idle, what exactly it is going to do. Okay, for that this is a solution. In case of one persistent, you can just observe this diagram. This is an example or indicate how one persistent method works. So consider this is the media and this particular station. Okay, consider there is a station B. It finds it is going to check the media continuously. Okay, so as and when it is checking continuously, it is finding that it is busy. You can just see continuously it sends the media. If it is busy, it cannot do anything. It has to wait. Okay, and once again check the media. Still, if it is busy, then go back and send the media. Okay, this process is going to repeat as long as media is busy. This blue color, you can see, no, this indicates the media is busy. Okay, at this time, you can just observe at this time, in case if media is not busy, if it is idle, okay, if it is idle, then the station is allowed to send the data. Okay, if the line is idle, the station sends immediately. Okay, with the probability equal to 1. Then if the line is busy, the station continues sensing the line. As long as it finds the media is idle, it will be keep on continuously, it will sense. It is like your for loop. Okay, it will keep on execute your for loop as long as your condition is true. Okay, once condition is false, then what it is going to happen? It will come out of the loop. Same thing it is going to happen. Continuously it will sense the media. So here the term continuously, that is very very important because there is a modified version of this in the second method. So this method has highest chance of collision because so two or more stations find the line is idle. Okay, so I can take one diagram here. Hopefully it is visible. So here what is the situation? Okay, when exactly there may be a collision in this method, one persistent. So I think you understood what is one persistent. Okay, let me just before going to the collision, you can just observe here there is a flow diagram. Okay, so this is looping statement. What you are checking in the loop? So the system or the station is checking is it the channel is busy. Very simple diagram. Okay, whatever this one persistent here it is shown, that is represented in the form of flow diagram. Okay, this is for loop. So what is the condition you are checking in the loop? Channel is busy. Okay, if condition is true, it will go back and once again it will check. Still busy, go back and check. If it is true, channel is busy, true means the media is used by some other station. Now this station cannot send. In case at some point of time it checks channel is busy, maybe it is false. Okay, in case if the media is free, if it is idle, not used by any of the station, in that case that particular station can transmit the data. The particular station can transmit the data. Okay, so this is to decide when to send the data. Next, so what is a situation in which there may be a collision? Okay, so here I've just taken set of stations or the devices connected to a shared media. Okay, so this method has highest chance of collision because two or more stations find the line idle. So your line means media. Okay, so consider this particular station at time t1. It finds, consider it is idle. The media is idle and it is going to start sending the data. At the same time, okay, at the same time, even this station also finds the media is idle. Okay, this station also finds the media is idle. Then this station also sends the data because the first bit of the frame it is not yet reached here. That's why this station finds that media is idle and this station also starts sending the data. Okay, at some point of time, so the both the data from station A and station B met with collision. It is going to met with a collision. Is it clear? So that is one thing. And after collision, what happens? It has to resend the data. So once again, if the both the station try to sense the media at the same time, okay, and finds it is idle, once again it will send the data. And at some point of time, once again there is a collision. Okay, so this is a problem with the one persistent. Okay, whenever two or more stations may find the station media is idle and both the stations start sending the data. Okay, consider this data maybe arrived here and this station start sending the data. Okay, at some point of time both the data may go with a collision. Okay, this is how one persistent method works. So let me move on to the non-persistent method. So what is the difference between these two? You can just observe the diagram here. Okay, observe the diagram. So this is in case of persistent. You can just see continuously the station is checking for the system is busy or not. Okay, but here there is a condition. Okay, it is going to sense periodically, not continuously. You can just see there is a station that is trying to sense the media. It is finding busy and it will wait for some time. It is not going to check immediately. It will wait for some time, then it will check the status of the media. If it is still busy, then it will wait for some more time. Okay, then once again it will sense the media, and if it finds it is idle, okay, then this station can start sending the data. Okay, and you can just observe this waiting time, it is going to be random. Can you see the length of the waiting time here and here? It is different. Maybe here it was waiting for 2 seconds and here it may be waiting for 3 seconds. The waiting time is taken randomly. I think you know in C program you have a random function. Okay, randomly you can choose some number. The same thing it is going to applicable here for finding the waiting time. You can just observe the flow diagram. Okay, so in the loop what you're checking, once again channel is busy. Okay, if it finds busy, the condition is true. That means wait randomly. Okay, wait randomly, whatever the random number it comes, no, so much of amount of time the station should wait. Okay, then come back here. After that waiting time is over, once again check the channel is busy. Okay, if it is true, it repeats with a different random number, and at some point of time once again it checks channel is busy. Okay, if it is false, then it indicates the media is idle. Okay, so then station can transmit the data. So this is a mechanism used in non-persistent. So instead of just continuously sensing the media and sending the data, so here it is going to wait for random amount of time. So by doing this, what happens? Okay, if another station is also waiting, or if it is waiting for the media to be idle, okay, it is going to be choosing the random amount of time. Okay, so the possibility of both the station getting the random time, random number of same random number, it is very rare case. Okay, in that case the collision can be reduced compared to one persistent. Okay, so before sending a frame, station sends the line. If the line is idle, the station sends the data immediately. If the line is busy, the station waits a random amount of time, then sends the line again. Okay, this method reduces the chance of collision because two or more stations will not wait. Okay, this is very important. How it is different from the one persistent. Two or more stations will not wait for the same amount of time because you are running random number here, random function. So the possibility of getting random number for both the station, it is very rare. Okay, not you are going to get that random number very frequently. Definitely both the numbers will be different. So because of this, what happens? The collision can be reduced. So maybe the first station may be getting waiting time 2 seconds, and the next other station, if it is checking with the same thing, the media status, it may be getting 5, number 5. That means it has to wait for 5 seconds. Okay. So after 5 seconds, so here after 3 seconds, the one station can check the media. If it finds idle, it can send it. Okay. And which is waiting for 5 seconds. Okay. That may find that once again the media is busy during that time. Will not retry to send simultaneously. Okay, simultaneously it is not going to sense the media to check the status because you are using a random number. So that is a main difference. so that the amount of collision can be reduced compared to one persistent. So next we have P persistent. Okay. Are you getting any queries? Let me just explain this. If you have any queries, you can ask. So P persistent. The next method is P persistent. So this method is used if the channel has time slot with slot duration equal to or greater than the maximum propagation time. Okay, so this works based on the time slot. So you just remember what is the meaning of time slot. We have discussed in slotted aloha like that. Okay, the concept is different. So what is the slot duration? If I take, this is the media. Okay, so you can just take different diagram here. Okay, this is a slot duration. So what exactly, how this slot duration is fixed? So this slot duration is nothing but propagation time. That is how much of time it takes to send the data from that particular node to the destination node. How much time it is going to take. So that time is set as a slot time. Okay. So if this particular station is sending data within the slot or propagation time, during that time no other devices are allowed to send the data. Okay, so that's why that complete slot is specified with the maximum propagation time. Why it is called maximum propagation time? Why they are using maximum propagation time? It depends on the distance. Okay, so how far the distance, if the distance of source and destinations are too far, obviously propagation time is going to be more. Yes, no? So in that case, so here they have given the slot time. So that is whichever the device that is having higher propagation time, so that time is set for the slot duration. Okay, so what are the advantage of this method? So it combines the first and second method. Okay, combines the advantage of other two methods, that is one persistent and non-persistent. It reduces the chances of collision and improve the efficiency. So here you can just wait, observe the diagram. So this is, you can observe here, continuously it sends the media. Okay, sends if if the random number is less than or equal to p. Okay, so p persistent, so that is wait a time slot, otherwise. Okay, so it has to wait till whatever the time slot it is given for the device. And one more point I forgot to tell is, for each of the device the slot is defined. Okay, so for each of the device the slot is defined. So only during that slot time, you just recall whatever we have discussed, TDMA, no? TDMA. Okay, so during that slot only the station should send. If it is okay, finds media is free, but if it is the not allotted slot, then station should not allow to send the data. Okay, that is very, very important. So continuously sends the media, sends if R is less than P, wait a time slot, otherwise. Okay, so if it is less than, it has to wait for its time slot. Then you can just check here, it is finding that wait for back of time. So wait for back of time means when it is sensing the media at this time. So if the station finds it is busy, it has to wait for back of time. So that is, once again, it has to wait for a random amount of time. Back of time, you just recall in the previous class also I explained with respect to pure aloha. Then send if R is less than P. Okay. So R is less than P, and in case if it finds the media is busy, but still if it is not the slot allotted to that particular station, then it has to wait for its own slot till it gets its own slot. So this process continues. Okay. Only during that, once if that particular time slot period, if it is assigned for the station, if it is crossed, okay, it cannot send the data even the media is free. Okay, that is the condition. It is specified in P persistent. Okay, channel is, okay, it is free, it has to wait. Okay, if it finds false, if it finds false means now media is idle. It is not the meaning that the station is allowed to send immediately. No. So generate a random number. Okay, so 0 to 1. So random number should be generated from 0 to 1. Then you need to check that R value, random value with P. Okay, so that is the probability value. Okay, so P persistent we are using now. What is the persistent time? So if it is less than or equal to, if condition is true, then station can transmit the data. In case if this condition is false, that means R is greater than P, it has to wait for its own slot. Okay, that means the slot is missed even though media is free, but it is not the allotted slot. So the condition is going to fail. So wait a slot. Okay, once again check for channel is busy. If it is busy, condition is true, use back of process as through collision is occurred. Okay, back of time, back of process means it has to go for a waiting time. Okay, it has to wait for some amount of time, then afterwards it has to check the channel is busy or not. Immediately it should not check the channel is busy or not. Okay, back of time means it has to wait for some amount of random amount of time, then later it has to check the media status. Okay, if it finds true, okay, still if it is true means the media is busy. Once again it has to wait for random amount of time, then it is going to keep on repeat this. How long? As long as the channel is idle. Okay, so if it is idle, if this condition is false, okay, it will go back. Okay, it goes back and once again it will generate the random number 0 to 1 and it will check the condition. Okay, it will check the condition. If condition is true, okay, the station can transmit. Otherwise it has to wait for its own slot allotted. Okay, after the station finds line is idle, it follows these two steps. Okay, so this is the first condition. I told the condition here, if it is the station is idle means the station is not allowed to send immediately. It has to follow two steps. Okay, with the probability P, the station can send the frame. Okay, with the probability P, the station can send frame. Okay, so with probability, that is Q is equal to 1 minus P. When I use the term probability, you should understand it is 0 to 1. Okay, so with probability Q is equal to 1 minus P, the station wait for beginning of the next time slot and checks the line again. Okay, it checks the line again. If the line is idle, it goes to step 1. Okay, if the line is idle, it goes to step 1. If the line is busy, occurred, assumes collision has occurred and uses the back of procedure. So this condition. Okay, so after waiting time also, if the channel finds it is busy, okay, it has to wait for back of process. That means it has to wait for some amount of time, then later it has to check the media. Okay, if I'm not using back of time means it is like this, continuously it is going to check the media. So back of time means it won't try to check the status of the media immediately. It will take for some amount of time, then it will check the media status. Okay, so what is the main thing in this method is, even though channel is busy, idle, it cannot send the data immediately. Okay, it has to wait for this random number. Okay, random amount of time, and also it has to wait for beginning of the time slot. Okay, so it can send the data only beginning of the time slot. So this is how the p persistent method works. Any queries? Okay, all these three methods comes under persistent, one persistent and p non persistent and p persistence. So any queries? If you have any queries, you can just ask me now itself.
No, no query.
So let me just go back. Did you people understood the problems whatever I taught in the last class? Did you check the textbook? Yes. Okay. So in the last class, I explained about pure aloha and slotted aloha. I don't know how many of you have tried. I told you people to go through the textbook. Okay. I think in old scheme, many times they have asked the problems with respect to throughput of pure aloha and slotted aloha. Very simple problem. If you know this formula, you can easily calculate. So this is the formula used for calculating the throughput of pure aloha. So here what is G I told? So G indicates average number of frames generated by the system during one frame transmission time. Okay. So that is how many number of frames generated during one frame transmission time. That is called G. So in this case, what is the maximum number of or what is the maximum throughput using pure alpha is 0.184, that is when G is equal to 2. So why G is equal to 1 by 2 we have taken? Because we know that vulnerable time of pure alpha is 2 times the frame transmission time. Okay, so the station generate only one frame in this vulnerable time. So it can generate only one frame. That means only one frame can be sent successfully. So this was a problem. Okay, I'll just go with one case. B and C, you try by yourself. A pure aloha network transmit 200 bits frame. Okay, 200 bit frames on a shared channel with 200 kbps. Okay, what is the throughput if the system produces 1000 frames per second, 500 frames per second and 250 frames per second? So now you need to calculate what is the frame transmission time first. So frame transmission time is nothing but, so what is the, that is packet size or frame size divided by the speed. Okay, what is the speed of the or bandwidth of the channel? Okay, so frame transmission time in this case, it is packet size, frame size is 200 divided by, and speed is 200 kbps. So in that case, the transmission time you are going to get, it is 1 millisecond. That means to transmit one frame from station to one end of the station to the other station, it requires 1 millisecond. Okay, so if the system generates 1000 frames per second, understand, if system generates 1000 frames per second or one frame per millisecond. Okay, I am just converting this second to millisecond. Okay, if it is in terms of millisecond, it can send only one frame per millisecond. So in that case, you can consider G is equal to 1, then S is equal to G into e power minus 2G. Substitute the value of G here. Okay, you are going to get 0.135, that is 13.5%. So in the question they've asked for 1000 frames. So this is your calculating for only one frame. So now You need to calculate throughput. What is the throughput? That is 1000 into, okay, 1000 into 0.135. That is equal to 135. 135 frames sent successfully out of 1000 frames. Okay, and remaining all met with a collision according to this pure aloha. Similarly, you just calculate the second case, 500 frames per second. So just convert what is the time taken for millisecond. It is 1 frame per millisecond. If this is the case, the value of g becomes 1 by 2. Okay, 1 by 2. You just substitute the value of g and calculate. You are going to get 0.184. Okay, that is 18.4%. So for 500, 500 into 0.184, that is 92 frames sent successfully out of 500. Similarly, you just calculate for 250. Okay, and similarly, you can just calculate for slotted aloha. Only the formula is changed. Okay, for slotted aloha, the throughput is S is equal to G into e power minus G. Use this formula. The same problem. Only thing is the formula is different. I want you people to try by yourself. Okay, so this is already explained. Okay, we have CSMA CD next protocol to be discussed. Then CSMA CA. So what is CSMA? Carrier sense multiple access. CD stands for collision detection. So let me just explain in brief about this. In the next class, I will continue the implementation of this method. Okay, I'll just take 2 or 3 more minutes. Okay, the CSMA CD. Okay, the disadvantages of the CSMA, whatever we have discussed in the previous protocol, that is the CSMA, carrier sense multiple access. The advanced version or improved version of CSMA is called as CSMA CD, that is carrier sense multiple access with collision detection. Okay, CD stands for collision detection. So CSMA does not specify the procedure after collision has occurred. Okay, like in case if there is a collision, what is the next procedure? So what about the frame that is met with a collision? How it has to be taken care? Is it just resending is the only the solution, or what is the solution to be considered? Okay, so that is one drawback of CSMA, where it is not specified in case if there is a collision has occurred. Okay, the solution for this drawback of CSMA is CSMA CD. Okay, so this enhances the CSMA to handle the collision. So here how it works, that is a station sends a frame, then monitors the media to see if the transmission was successful or not. Okay, so it sends the frame. It's not going to just relax after that. It has to monitor. Okay, whichever the station it is sent the frame, it has to ensure that the frame is reached the destination or the specified address successfully. Till that it should be in monitoring state. Monitor the media to see if the transmission was successful or not. Okay, so that is added here in the CSMACD. Then if the transmission was unsuccessful, okay, unsuccessful means consider there is a collision happened during transmission of that particular frame, and it should be sent again. Okay, if there is a collision, it should be sent again. So I will show you the diagram for that. You can just observe the diagram. So here there are 4 stations that are connected through a shared media. At time t1, okay, at time t1, you can just note down this is time t1. What is happening at time t1? Station A has executed its procedure and starts sending bits of its frame. Okay, what is the procedure here? It will sense the media, and if it finds free or idle, that it is going to start sending the frame. Okay, it is start sending the frame. At time t2, station C executed its procedure and start sending bits of its frame. The collision has occurred at some time after time 2. So you should know how exactly the collision is going to occur, because the first bit of A, if it is not reached to station C, okay, in that case, the station C, it finds the media is idle. Okay, it finds the media is free. Then it is going to start sending the data. Okay, at some point of time after time t2, you can just observe here. Okay, after time t2, so this is t2, time t2. So if it finds after time t2, so there may be a possibility of collision occurs. That is, the data of station A may collide with the data that is sent by station C. The first bit of A is collide with the first bit of frame sent by station C. Okay, so this is like how to detect the collision, and you can just observe what happens next. Is it after knowing also the station should keep on sending the data? It's meaningless. Okay, the station, if it finds the data is met with a collision, then it has to stop sending the data. Okay, it has to stop sending the data. That particular station should stop sending the data, and immediately it should abort the operation. So station C detects collision at time t3. Okay, so this is the time during which data is sent, and this is the time during which, okay, so it finds there is a collision, that is time t3. When it receives the first bit of A's frame, the station immediately aborts transmission. Okay, because if it is not just started sending the data, so once it finds there is a collision, it should stop sending the data. Otherwise, it is a waste of time, and the media also it is not utilized efficiently, because after knowing also if it is keep on sending the data, so the data is corrupted. Definitely, it will be corrupted. Then it has to resend once again. Instead of doing that, as soon as it identifies there is a collision, okay, so the packet is met with a collision, then immediately it should abort. Abort means stop sending the data. Okay, at time t3, station C finds there is a collision, and immediately it will abort. It is not going to proceed sending the remaining data. And at time t4, okay, at time t4, the station A detects that there is a collision. Then station A also immediately abort the operation. Okay, so this procedure was not there in the previous method. Okay, like if there is a collision, what is the step to be taken? That was not told in the previous method, CSMA CA. Okay, so that is the only one additional thing that is added in CSMA CD. Okay, so station A transmit for duration of T1 to T4, and station, so this is the duration, and this time whatever the data it is sent, okay, that is like met with a collision and it has to be resent. And time duration T3, T2 to T3, okay, so that is the time duration of the data sent by the station C. For the protocol to work, the length of any frame divided by the bit rate must be more than either of these duration. Okay, so whenever if it is checking what is the time it requires to send the data, okay, for that you need to check the bit rate and what is the size of the data it is sending. Okay, based on this, the duration should be set. Okay, the detailed procedure we'll discuss. It will take a lot of time. Maybe I may not able to complete the remaining part. We'll discuss the remaining part in the next class. Okay, so with respect to vulnerability and what is the frame size you need to speak, so all those things we are going to discuss in the next class. So any queries you can ask now.